Hello, everybody. Today we're beginning our chapter 12, and we're going to be solving some simple, basic trigonometric equations. And we did a little of this in lesson 7 when we had the calculator usage. So you're going to need to be able to use your calculator. And the other thing we're going to have to do right now is make sure our calculator is in degree mode. So we needed radians for graphing, but if you recall, for everything else, we need to be in degree mode. So now we need to go back to that. So please make sure you turn on degrees. All right. So this first problem says, in each of the following, an angle is given. Determine its reference angle and then use your calculator. So now we are going to use our calculator and we're going to use decimals, because the other thing they're telling us that lets us know we have to do that is this right here, to the nearest hundredth, which means 2 decimal places. So if they say exact, you have to use the triangle and go back to everything we did in chapters 9 through 11. But now if they're saying hundredth, we're using the calculator for all of this. So the first thing we want to determine the reference angle. So that is going to take us back to the very first thing that we've done. And if I draw myself a little set of axes, and now I draw myself an angle, here about would be my 120 degrees. But they need us to find the reference angle. So as you recall, the reference angle is what we get when we reference this 180 degrees over here. And that makes this a 60-degree angle. So then it says find the sine and the cosine of the angle and its reference. Well, that's the one thing that is pretty important to make notice of. If you are going to find the sine and the cosine of the angle, it is going to be exactly equal to the sine and cosine of the reference angle, because the reference always brings us back to a positive acute angle. So this was not acute. 120 was obtuse, but 60 is acute. So I'm going to use the typewriter now. Oh, let me get smaller. All right. So if I found the sine of 120 degrees using my calculator, I can simply type in sine of 120 degrees. And if I round this to the nearest hundredth, like they say, I have 0.87. Oops. So this equals 0.87. Now, watch what happens when I find the sine of the reference angle 60. So now I'm not going to clear that out yet because I'm not going to clear out all this. Now let's do the sine of 60. Exact same thing. You get the exact same thing because an angle and its reference angle are the same value. Now, the positive and the negative again is always about location. So let's take a minute and look now, if you will, at the cosine of 120 degrees. So now I need my calculator, and now cosine has a negative x coordinate. So watch what happens. Cosine of 120 degrees is negative 1/2. Now, if I type in the reference, the cosine of 60, I get positive 1/2. What's the difference? The difference is the location. I'm just going to type in these items that I don't have yet, and then we'll go over that. Okay. Now, the reason why this 60, even on the calculator, would be positive, remember, 60 degrees would have been in quadrant 1. But this is a reference angle now. This reference angle, and I'm going to actually write right below it, this reference angle is 60. This is what we did in chapter 9. We said, okay, cosine of 120 degrees is equal to negative cosine of 60 degrees. And the negative down here meant, the negative down here, get to it right now, means quadrant 2. And let's draw a little arrow. So this means we are in quadrant 2. So we're going to start this lesson by going back and remembering. Let me just see. Lock this in place so I can move things without destroying the whole board. Okay, so now. All right, so now that fits there. Now let's talk about 200. Now 200 means we are an angle that is, whoops, go back. This 200 means we're an angle that's terminating in quadrant 3. And I know I'm terminating in quadrant 3 because I have to go beyond 180 into 200. So this 200-degree angle here, so this arc is my 200-degree angle. See, there's the arrow for it. But now, if I want to talk about this as a reference angle, I have to access the x-axis. And the x-axis, again, is 180. So you think about 200, and you say, I went 20 degrees beyond 180. So that's why this is a reference angle of 20 degrees. Let's go back again to what we talked about with sine and cosine. So now the sine of 200 degrees is located now in quadrant 3. In quadrant 3, my y down here, which again, this is what I get my positive and negative from. My sine is negative because my y is negative. So if I were to now talk about this in terms of a reference angle, this would be negative sine of 20 degrees because I'm in quadrant 3. The negative now is referring to quadrant 3. So that means quadrant 3. So back to the calculator. If I were to type in the sine of 200, I get this negative number. If I were to type in negative sine of 20, the exact same number, negative 0.34. So let's type that in now. So this now is equal, both of them, negative 0.34. And we're also in quadrant 3, so that's going to affect cosine. The cosine of 200 is also negative in quadrant 3 because the x-coordinate is negative. That's a negative x up on the graph. So this is equal to negative cosine of 60 degrees. And that is going to give us what? So cosine of 200 is negative 0.94, and negative cosine of 20 is also negative 0.94. Oops, what did I write? So these both are negative 0.94. So you should maybe try to pause the tape right now and do C without me. If I do C right now, C is 310 degrees. 310 degrees will land me all the way in quadrant 4. Now, quadrant 4, again, we have to consider sine is y is negative in quadrant 4. But x is positive and cosine is the x. So sine is going to be negative, whereas cosine is going to be positive. Just like on example 1, when we landed in sine's quadrant, sine was positive where cosine was negative. In B, we landed in tangent's quadrant, making both sine and cosine negative. But now we're in C, where again, y is negative, that sine is negative, x is positive, that makes cosine positive. So let's take a look at what we get with this one. So now we have the sine of 310 degrees is equal to negative sine, and now we have to reference to 360, which would be a 50-degree reference angle. And we'll type that in to see what that makes. Again, cosine now is going to be positive because 310 degrees is in quadrant 4, which is cosine's quadrant. So the cosine of 310 is going to give me the exact same thing as the cosine of 50. So let's type those in and see what we get. So the sine of 310 degrees is negative 0.77, and negative sine of 50 is still negative 0.77. Cosine of 310 is 0.64, and the cosine of 50 is 0.64. So the sine gives us negative 0.77, and the cosine gives us 0.64. Oops. So now that's a review to help us with what we're going to be doing next. Here it says consider the trigonometric equation. Now I have an equation. This is what we were doing when we did lesson 7. Determine the reference angle for this problem. Well, if I'm going to get the reference angle, and this is saying I am between 0 degrees and 360 degrees, and sine is negative. Now, if I think about this, I'm actually going to do part B first, because if I'm thinking about sine being negative, and I go back to my all students take calculus, sine is positive in quadrant 2 and positive in quadrant 1. That means this problem here, because of the negative, is telling me that this is going to be in quadrant 3, which means this angle is going to be bigger than 180 and less than 270, or this angle is going to be bigger than 270 and less than 360. So I am going to possibly have two answers to this one problem. So let's now go back over to here. If I have the equation,
I can't believe that happened again. I don't have any idea.
If I have the equation that says the sine of theta is equal to negative 1/3, so my typing isn't going to be as nice as we would like, but it's better than trying to write with the mouse. So sine of theta is equal to negative 1/3. And if I want to get theta by itself, if you remember from lesson 7, the sine is the guy that's got to come over. Now, when you bring the sine from one side of an equation to the other and you're solving for your theta, that's called the arc sine. So when you do this and you bring the sine over, sine to the negative first, this is my arc sine of 1/3. This is going to tell me my angle. So let's take a look at this on the calculator. I'll clear out all this other stuff. So now if I have the arc sine, second sine, and I have in 1 divided by 3. Now, notice I didn't put the negative because this is giving me the reference angle. So if I am rounding this to the nearest tenth of a degree, this is a 19.5 degree reference angle. Now that's going to be pretty important because once I get to here and I say, okay, this means that theta is a 19.5 degree reference angle, that means what happened over here is I went beyond 180 by 19.5 degrees. So in quadrant 3, in tangents quadrant, now sine would be negative, so there's my negative, check. And 19.5 degrees plus 180, so if I put my 19.5 in, this tells me that my angle is 199.5 degrees because 180 plus 19.5. So I am going to use the typewriter and let me just. Theta is equal to 180 plus the reference, and that gives me 199.5 degrees in quadrant 3. I'm going to actually move that down now so we can read it. So, but what about when I take this reference angle and I go back to here where I know that I'm negative in quadrant 4. So here's my reference angle of 19.5 now in quadrant 4. Well, yes, I went all the way around. I'm bigger than 270. But the fastest way to do this is to reference the 360. So if I reference the 360, I now have this, I would say, theta is equal to 360 minus the 19.5 because I hit the 19.5 below the axis if I'm drawing that. So 360 minus 19.5 gives me a 340.5 degree angle in quadrant 4. So I basically did B and C here on the picture, and so here's the answer to D. I hope you were able to follow that. Again, you should always stop, go back over this, make sure it's sinking in as I'm going. I'm trying to go slow. I want everybody to be successful. So they gave you on the top of the page these steps to follow. So let's go through this one now. On all these problems, we're going on a full graph, and cosine now is positive. Before you do anything, you always want to think through the signs. So for A, if cosine is positive in quadrant 1 and in quadrant 4. That tells me that this guy here, when I solve for theta, and again, to solve for theta, I am going to have the arc sign. So theta is going to equal cosine raised up to the negative first power, the arc cosine, of the fraction 2/3. And that's going to give me my reference angle. So what's my reference angle going to be? Let's get to the calculator and find out. If I now type that in, arc cosine of 2/3, I get a 48, and this says to the nearest tenth of a degree, so a 48.2 degree angle. So I come back over here. My theta is equal to 48.2 degrees. And in quadrant 1, that's what I'm going to be. I'm a quadrant 1 angle, so I'm going to stay 48.2 degrees in quadrant 1. But now, the 48.2 degrees is the reference angle in quadrant 4. So theta in quadrant 4 is going to equal 360 minus 48.2 degrees, and that is going to give me 360 minus 48.2, 311.8 degrees. Whoops. I got clicking in the wrong spot. 311.8 degrees in quadrant 4. I hope this is making sense. I hope you're following along and you're feeling more comfortable with this. Sine is positive, so this is going to tell me that sine is positive in quadrant 1 and 2. So now to solve this equation, my theta is equal to the arc sine -1. Nope. Try it again. Sorry about that. There we go. Of 1/2. I need my calculator for this. So let's clear all this other stuff out. So the arc sine of 1/2, 30-degree angle. So this is telling me that theta is 30 degrees in quadrant 1. This is also telling me that in quadrant 2, a 30-degree reference angle in quadrant 2, that my theta is 180 minus my 30 degrees, which is a 150-degree angle in quadrant 2. So everything about where we land is all about the sign of what we were given. Cosine here now is negative. Well, now we want to say that cosine is negative in quadrants 2 and 3. So I am going to find my reference angle by the arc cosine. So theta is equal to the arc cosine of 0.47. Again, I don't put in the negative because the negative was the location that I already took care of. So on my calculator now, if I type in the arc cosine of 0.47, my angle is 61.965. This rounds to 62 degrees because rounding to the nearest tenth, I got to round up. So this now would be 62 degrees. And this is my reference angle. So if I've got a 62-degree reference angle, now what I need to do is say, okay, theta in quadrant 2 is going to be equal to 180 minus 62 degrees, which is going to give me a 118-degree angle in quadrant 2. And then theta is going to equal 180 degrees plus 62, which is going to give me a 242-degree angle in quadrant 3. So this is really tying together so much of what we've done over the last couple of weeks. And we have to always consider where we land. Now, if you could solve a regular equation, that you've been seeing ever since you started school, you can solve these equations. Take a look. 5 sine of alpha minus 2 equals 0. Well, if I'm going to solve this equation, I am going to add 2 to both sides. And when I add the 2 to both sides, what I'm going to get is 5 sine of alpha and I'm not, oh, here it is, okay. 5 sine of alpha is now equal to the 2, and then you have to divide both sides by 5. So then we're going to end up with the sine of this alpha is going to equal 2/5. Well, this is now just like the work above. You say, okay, sine's positive, so now we take a moment and we write down, you know, where we're located because of the positive sign. So sine is positive in quadrants 1 and 2. So once I now solve for alpha by using the arc sign, of 2/5, let's see what we get. So now we have the arc sine of 2/5. And they say 1/10 of a degree again, so we get 23.6 degrees. So this now tells me that this is equal to 23.6 degrees. And that would be in quadrant 1. If I go to quadrant 2, then that is when I'm going to subtract this from 180. So this alpha is now equal to 180 minus 23.6 degrees. And that gives me 156.4 degrees in quadrant 2. And you're going to do the same thing with this guy. I'm going to actually try to use the mouse to maybe move this along a little bit. I think you're getting the hang of it. You're going to subtract 1 from both sides. And now you have 2 cosine of alpha is equal to -1. Being that it's negative, you're going to now consider what quadrants we'll be landing in, and cosine of alpha is -1/2. So if I solve for alpha first, I get my angle alpha is the arc cosine of 1/2. And let's find out what that would be. So the arc cosine of 1/2 is 60 degrees. So this means now that my angle alpha is a 60-degree reference angle, and it's going to be in quadrant 2 and quadrant 3 because of the negative. So again, let me draw this one out with the pen. Cosine is negative in quadrant 2 and quadrant 3 because of the x. So here's my 60-degree reference angle in quadrant 2, and here's my 60-degree reference angle in quadrant 3. So what are my angles going to be? Well, in quadrant 2, I stopped short of 180 by 60. So that would be 180 for the angle, or for the axis rather, 180 minus 60. This is a 120-degree angle in quadrant 2. If I go to quadrant 3, I went 60 degrees beyond 180, 180 plus 60. This gives me a 240-degree angle in quadrant 3. So if I take a moment now and I type this up nice and neat, I would say, okay, alpha is equal to 120 degrees in quadrant 2, and alpha could be equal to 240 degrees in quadrant 3. So tonight I'm going to ask you to finish this packet, all except for number 9. So you have the fluency or skills, whatever they're calling it, skills on this packet. And we're going to do all that except for number 9, because that's going to bring us into a quadratic. I think that would be quite difficult, but I'll tell you what, if you decide you want to give number 9 a try, you know, make sure you highlight that so I can take a look, and you know, you can do that and you do it successfully. Well, that would definitely be worth some bonus points. All right, good luck, guys.